All right, folks, in this video over here, we're gonna dive deep into page 92 and also 93. So let's take a look at the example question. Find a range of the values of a constant k so that each given quadratic equation has two different positive solutions. So very important information over here is that we have two different positive solution. And it tells you that alpha is greater than 0, beta also greater than 0, alpha is smaller than beta. So in my mind right now, what I can picture right now is that this is my Cartesian plane, right? This is my y-axis, this is my x-axis. And if I have two positive solution, it could be something that looks like that, right? Two positive solution. It could be something that looks like that, right? Also two positive solution. What it cannot be is it cannot be something like this or like this. So we're gonna take a look at a graph over here too, and you will understand that what are the criteria for us to make it possible. Okay, so with that being said, let's take a look at this question. So we have the target equation, which is x squared minus 2kx plus k plus 2. So don't be fooled by all these long k's. All you need to do is that we have our standard polynomial form, which is ax squared plus bx plus c. In this case, our b is negative 2k, our c is k plus 2, and our a is 1, right? And very important is what's our formula for our axis of symmetry? So it's negative b over 2a. So whatever you are dealing with quadratic functions, just remember that your axis of symmetry is always negative b over 2a. So in this case, right, what's our axis of symmetry is what's our b? Our b is negative 2k. And our a is 1, so this will be 2. Canceled out, k, so that's why my axis of symmetry, we call it AOX, all right? AOS is going to be k. So that explains number 2 over here, why it has to be greater than 0. Because if you look at a graph, this is again our Cartesian plane, okay? If my axis of symmetry is right over here, let's say, on the left side, which means that my graph has to be looking like that, which means I only have one positive, one negative. But if it's right here at 0, I also would not have two positive. So my axis symmetry has to be positive over here in order for me. Let me just get erased everything so that now I have a clear picture. Okay, my axis symmetry has to be greater than 0 in order for me to have anything that even had the possibility of two positive roots in this case. Okay, so let's look at number 1 over here. So it says d over 4. So if you should be very familiar with this one. D over 4 is basically, instead of doing d as a discriminant, we're using the short version of discriminant, which is d over 4. So k squared minus bracket k plus 2. This is really b prime to the power of 2 minus ac. B prime in this case is our negative k. All right, so negative k to the power of 2 minus a times c, which is 1 times k plus 2. That's why you're getting the k plus 2 over here, okay? So k squared minus k plus 2. So in this case, we have to factorize it. Once we factorize it, we get k plus 1 bracket and k minus 2 has to be greater than 0. So how do I analyze this? This is actually quite simple. If you draw a little graph over here, so let's try this way. Let's see, we have negative 1, right? But remember, this graph, specifically, we're actually dealing with k, all right? So if I have negative 1, I have 2 over here. This is how my graph look like, right? Potentially, that's how my graph look like. And if I want it to be greater than 0, there's a couple ways there's going to be greater than 0. Is that as long as my k is right here, right? And also as my k is going to be right here. So which means that k has to be smaller than negative 1, right? That's basically on the left side of everything, right? Smaller than negative 1. Or k has to be greater than 2 on the right side of this. This is 2, this is negative 1, okay? So that explains from here, k smaller than negative 1, and also k greater than 2. And another thing is, in order for me to have two positive solutions, my y-intercept has to be greater than 0 too. So you might want to ask, hey, Tony, why does it matter? How come my y-axis has to be greater than 0? So if you look at a graph again, okay? If we're drawing a Cartesian plane, let's explore our options. Let's say if my y-intercept is right here, which is greater than 0, I have the possibility of the 2 positive. But, watch this, okay? If my y-intercept is right at 0, you see what happened? I only have one positive and another one is actually 0. So that does not fit in this criteria. However, if I have a negative, all right? If I have a negative one, negative y-intercept, what will happen? You will see that guarantee you will have one negative and one positive, which also does not fit this criteria. So when we're doing questions like this, we have to think, okay, 2 different positive solutions. Immediately you're thinking, okay, my discriminant is going to be greater than 0. Why? Because that's the only way I have 2 different solutions. Next one is positive. How do I determine the positive? Oh, I know my axis of symmetry is going to be positive, right? Because that's the only way for me to even have the possibility have positive 1. But you might ask, Tony, so even though I have a positive axis of symmetry, I could be getting a negative. But did you see that? That's where when you see the y-intercept is, in this case, it's going to be 0. It's going to be negative. So what if I actually have a positive y-intercept? And let's redraw the graph. And now you have 2 positive, always. So only if we have all these criteria, right? Only if we have all these criteria, number 1, 2, 3, will I have 2 different positive solutions. So that's what this question is trying to get us to think and analyze, okay? So with that being said, let's actually try question number 3 on 92B. Okay, let's go through this one more time. So we also want 2 positive, right, solutions, and I'm assuming that the criteria is going to be the same. So the criteria is going to be the same. Perfect. All right, let's dive deep into this. You know this, how to find your discriminant, right? And it's quite obvious. We have this is going to be our B, this is going to be our A, and this whole thing here is going to be C. So our B prime is going to be K because the B is 2K, so B prime is going to be K. Just as a kind of review, B prime is basically equal to B over 2, and only if it's an even number. Okay, so that's how we use D over 4 in this case. Okay, all right, next. You already know axis of symmetry, negative K over 2. I'm not going to do the calculation over here. Based on the knowledge before, negative B over 2A. Substitute numbers in, you would get negative K over 2 in this case. We also want it to be greater than 0 as well. So tell me you know how to do this. A little trick over here is that you have a negative over here, right? So when you're analyzing that, make sure that you divide both sides or multiply both sides by negative. So then you're actually dealing with K plus 4, K minus 6, smaller than 0. So when you draw the graph, right, you have negative 4 and you have the 6 over here. When you draw the graph over here, you have it has to be in between negative 4 and 6. That's why this is the first one. Okay, so next. Based on our axis of symmetry, we also know that K is going to be smaller than 0. Again, based on that, you can multiply both sides by the negative, and then the sign change, K over 2 smaller than 0. So multiply both sides by 2 again, you have K smaller than 0. So that explains that. All right, and then we also have the y-intercept. We want it to be greater than 0 as well. So in this case, since my C is a quadratic function based on K, right? So K squared minus K. So we quickly do the factorization. We have negative 3 and 4. Again, draw the little graph based on the K. Negative 3, and this is 4 here. You want it to be greater than 0, so then it's going to be smaller than negative 3 and also bigger than 4. So that's what this is talking about. Then when we summarize and combine everything together, all you need to do actually is to draw a graph that looks like that, okay? But just by looking at it, you should have an idea as that what is the number, right, that actually fits in everything. In this case, it's going to be K in between negative 4 and negative 3. Very narrow, like it's very narrowed down after you analyze it. All right, so 93A. Okay, so before we're talking about positive solutions, right now we're actually talking about negative solutions. So the idea is very, very similar, but there's a couple things that I do want you guys to like think about, right? Before we're talking about the solutions going to be on the right side of axis, so y-axis. So it's not going to be on the right side, something over here. Right now, we want it to be two different negative solutions going to be on the left side. So what changes and what don't change, right? So one thing that I know for sure it's going to be changing is that my k axis of symmetry, it has to be what? Smaller than 0. So that explains this part. However, based on this, in order for me to have two roots that are on the same side, I want to make sure that my y-axis, my y-intercept is going to be greater than 0. So this doesn't change. And another thing is that because I have two different solutions, also my discriminant also don't change. So the only thing that really changes is the axis of symmetry. So anything else remains the same. So even for you to analyze the whole part is the same as well. So why don't we just pause the video over here, try question number 1, and if you can turn to question number 2 on page 93B as well, and try it out over here. And based on the solution manual over here, it should give you the step-by-step, and you just have to combine all the answers together. Okay, hopefully this video helps. If you have any questions, comment below or let me know. Thank you.